Now, let me discuss about the architecture of this BERT and GPT model. Both have similar architecture, but the difference is here in the GPT we make use of cross attention as well as masked self attention, so that we could not see the next word, so that we could predict it or generate it. Here in BERT it looks at all the context, means all the sentence of all the words of the sentence. Firstly, we have input. Input is going to be converted into embedding, that is the vector, and then we have a position and encoding, and then it moves to the self attention layer, and then it moves to the next, what is that, feed forward network, that is transformation layer, and then it moves to the next softmax layer, where the prediction will happen whether this word suits to the next position or not. Finally, we have the output. This is the common architecture in both BERT and GPT. Here we make use of different types of parameters. One is internal parameters, another one is external parameter. In internal parameters we have weights and biases. This is going to be used during the training. After the training, we froze it because it has less loss, because it is trained as well as undergone back propagation. And then we have biases. These two are the matrix based on which we know the parameters. That is, this model has 1 trillion parameters. It depends on the size of this weight matrix. And then we have another type, that is external parameters, that is hyperparameters. We use it during the fine tuning. After the training of the model, if we want to fine tune to this specific data set, then we make use of the fine tuning method, like LoRa method, etc. Here we use learning rate and batch size. Batch size mainly depends on the GPU memory, whether you use 8 GB VRAM or 16 GB VRAM, 32 GB VRAM. Depends on that, we have to give that amount of data, maybe 32 sentences, 32 paragraphs, like that. Depends on the GPU memory, and then the sentence length, how many words, how many tokens have in that sentence. So we use different types of functions in this architecture. Firstly, sigmoid and relu. These two are mainly used. These are non-linear functions after the linear transformation layer. In a sigmoid, the range is between 0 and 1. The formula is 1 by 1 plus e power minus x. This is going to be the formula for sigmoid function. For relu function, we have no formula, but if the value after the linear layer is less than 0 or negative, then those values will be considered 0. That is, no signal from that node. That is why we make use of leaky relu. In leaky relu, instead of this 0 substitution, we make use of 0.01x. At least some signal will be present rather than 0, because there is some knowledge may be present in that node in the neural network. And then there is another function, that is important function, softmax function. In softmax function, we make use of exponential logit, exponential power logit, divided by sum of all the words or logit vectors, exponential of logit. This is going to be summed in the denominator with respect to the numerator, the specific word. that is each word, whether this has higher probability or lower probability.